I'm going to move on and introduce our keynote speaker, Dr. Peter Boyce. You can either use that one.
Machine.
Yeah. Use the forward. I think it's working.
Yep. One thing, if there's one thing more dangerous than the man with the red flag, it's the man with the green flag as well. So this thing has got a pointer and direction, so I shan't use that. Okay. I'm going to be talking. Thank you. Yes. I'm going to be talking about the future of lighting research. So the objectives I've sort of tried to identify is to try and say what are the currently active areas in lighting research, why these areas are active, and if they are not, they are important, and then to ask where lighting research ought to be going, where it is going and where it's going to. And for those of you with a classical or biblical education, this is the Tower of Babel, right? Where it's been constructed by builders who didn't speak to each other. And as editor of LR&T, it sometimes feels like that. Right, so active research areas. Well, this is my image of a researcher. All right, you can see it's angular, so we've got plenty of metrics in there. It's also very colourful, which means we deal with colour. And somewhere in the middle of it is a pair of eyes. All right, so that's the image of the researcher, and what we've got is active areas in all these things: technology, measurement, design, performance, and health. Let's deal with technology first of all. Well, we've got the LED revolution sweeping the world, and sometimes you get the impression that LEDs are the answer. Now, what's the question, right? So what we've got is we've got two major areas of interest, and you've heard about one of them today. Some of the fundamental quantities that we use for describing lighting, well, for quantifying lighting, all those luminous fluxes, illuminances, luminous intensities, luminances, and so on, all to do with V lambda. But V lambda is based on just 2 photoreceptors, and we have at least 5, well, apart from those with red-green deficiency, we have serious red-green deficiency, by the way, we have 5 photoreceptors in the eye. Now, in fact, there's a case to be said that V lambda is actually a very sensible thing to do, in the sense that, if you think about it, how do we convey information to each other, other than talking? The answer is by reading. And why does that work? Because we know where the next bit of information is. We may not understand what it means, but we can predict where it's going to occur. And therefore, the V lambda, the foveal ability to see detail, is what matters. And that was originally what lighting was for. But now we've got a much wider range of interest. We've got people talking about lighting the space, although I see that has to be replaced by lighting for people now. And so on. So we've got a lot of that. And at the top there, let's see if I can get this to go. Top here we have all the various photoreceptors. The dotted one is the V lambda curve, and these are all the various cones and intrinsically photosensitive retinal ganglion cells. And there's a great deal of interest, I think, in seeing if we can, or if we should modify this, or so we say, add some additional photoreceptive curves to go with V lambda. The other thing we've got is colorimetrics. There's a great outburst of colorimetrics. Going back a long way, people originally thought that we were dealing with, what should we say? Yeah, we've got colour rendering index. It's what people have used for 50 years. General colour rendering index usually. And now the American IES has bitten the bullet and said, no, we want something better than that. So now we have a colour fidelity index, which is a better version of the colour rendering index, an average one. We have colour gamut, which gives you an idea of the degree of saturation that you're going to get with colours. And we also, incidentally, are moving away from pure numbers. All of a sudden, graphics have become interesting. How do you display something? I mean, trying to display something as complex as the wonderful world of colour with one number is a bit much. That's a real struggle. Graphics give you an idea of saying how's it going to work in different parts of the hue circle, which way is the distortion going to go, is the distortion desirable or not. The question that comes about with this idea is how far do you want to take it? Because if you're not careful, you finish. Because what's been found now is that it doesn't just depend on the area of the gamut, it depends on its shape. And that means that therefore you may have a light source which distorts things in one direction, but that may be desirable. But it wouldn't work with another thing. So do you make it, how complex can you make things to be? There's always a struggle between lighting design where you've got to meet lots of different people's ambitions and preferences in a common space. It gets complicated. So those two things are going on in that area. And because we've also got technology and control systems, the aim is to improve lighting control by using multiple sensor arrays of various sorts, using wireless communication, and of course we've still got the old one of making systems adaptive so that you can provide preferred conditions and you can combine them with daylight and electric light and so on. There's a lot of stuff being done on control systems. What about measurements? Measurement is interesting because, as we've heard earlier in some of the discussion just now, what do we want to measure? That's the problem, right? But we've got new techniques. We've got high dynamic range imaging, which allows you to take a whole large area, measure the luminances in virtually one instant. Very useful thing, but is it really a means without an end at the moment? We have the technology, but we don't know what we're going to do with it. What about design? Well, design is an area where there are two main themes going on, I think. One is driving the design away from lighting the work to lighting the space. And how do you design for people's perceptions of the space? And Kit Cuttle, as you know, has been rabbiting on, more rabbits again, been rabbiting on about excitance and so on as a means of delighting the space. And there's some interest in that. There's certainly papers being generated in that. And then also we've got, this one has been around for years. How do you deliver daylight efficiently and without discomfort, preferably to save energy, but also in these days to provide the right circadian stimulus and so on. And then we've got performance. Now, you may have thought that, well, should have thought, that all the things related to visibility have been sorted out. And by and large, they have. Well, on-axis visibility anyway. Once you get off-axis, it's a different matter. But there's a question here again. We talk a lot about different tasks. How do we combine them together? It's very rarely that you want one thing or the other. You want both, usually. You want to know where something is and what it is when you look at it. Right? The other thing that's becoming more of interest is examining the effects of performance of using lighting to stimulate the circadian system. And I'm using that in the broader sense. The problem, so you get strange things being marketed called dynamic daylighting and so on. Whether it's effective or not, I don't know. Road lighting, there's an awful lot of work being done on headlights, a lot of work being on lighting for pedestrians. That's the other big thing. Drivers seem to have got a bit lost, but basically it's qualifying lighting for pedestrians. And then you've got, oh yes, I like this one. I love this picture. That reminds me of my time as a graduate student, yes. I used to have to wear an enormous contact lens with a stalk sticking out the end of it with a mirror on the end. Didn't quite have a plug in the side of your head, but the idea was right. Right, so we know that the circadian system is fundamental to human functioning. It sort of sets the base level from which we can function. Light-dark cycle is potent in training that system. And exposure to light at the right time is important for maintaining human health. There's plenty of evidence to show that if you work night shift, well, not quite night, if you work regular night shift, that's okay. It's a bit like smoking. Now, some people can tolerate night shifts for years and years with no trouble. And people can smoke 40 cigarettes a day and live to be 95. But there aren't many of them. Most people find night shift, and particularly rapidly rotating shift work. And so there's a lot of interest in trying to find out exposure of light at night. How are we going to be dealing with that? What we know is, for instance, you'll hear a bit more about it from Mariana next, I believe, exposure to high light levels during the day and help those with damaged circadian systems. So Alzheimer's people are a classic case, and you can do something. You can't get rid of the symptoms, but you can make their life easier, and then you can make it easier for the people who care for them. But we also know that exposure to light at the wrong time is increased with the risk of ill health of various types. So there's a lot of work being done on that, but not much of it is being done by lighting people. Most of it is being done by medical people, right? Which is, as it should be, but it'd be a good idea. So, what is the current state of lighting research? Well, as I hope I've demonstrated, it's very diverse. It's increasingly sophisticated, and it involves knowledge from many areas provided by people with different types of expertise, hence the Tower of Babel. But the question is it relevant? Well, that depends what I mean by relevance. To be relevant, I think lighting research has to affect lighting practice. Right? For this to happen, the research has to address whatever you can do, why people change lighting. So among these things are legal requirements, fair enough. Most people try and design lighting to meet legal requirements. Make money. We all love making money, one way or another. If you fly Ryanair, you can always count the money you've saved, as long as it's a short flight. Improving health, that's a good driver. Improving performance, that sort of links back to making money. If you can make people work better, more productive, and more likely to stay with you, and so on. And then the last one is minimising environmental damage. That's another driver. People like to be able to, well, there's a lot of emphasis on being able to reduce or minimise environmental damage. You know, light pollution, all those strange things that people worry about. But you can see from what's happened with plastic bags over the last year how important that can be. So, what is the potential? What's potentially? Well, all the active research areas, apart from measurement, I think have a chance to be influential. And measurement is, to some extent, not missing. It's the key to a lot of the other things. So you've got to get the measurement bit as well. But probably, I think, the biggest potential is health studies. If you can convince people, or convince that if we can find light sources that do some of these things on health, that's a good thing. But we have to remember there are other sources of light than lighting systems. You know, there's a picture of a young woman sitting there with a tablet in probably some 2 o'clock in the morning or something, bathed in blue light. Yes, not a good idea. So what needs to be done to convert this potential to actual influence? Well, if you're a researcher, I think, what do you need to do? What do you need to do? Well, first of all, you can forget about influencing lighting designers. This is not to say that lighting designers aren't interested, but they're individuals. They do their own thing, and that's fine. And that's what they should do, because if they don't do their own thing, what's the point in them? Yeah? They have to do their own stuff. What you should concentrate is on trying to change lighting standards and guidance. Because a lot of people, designers in my experience, are very reluctant to move outside design, certainly legal standards, and sometimes guidance. Yeah? So there's plenty of scope. There's plenty of scope to do this, because electric lighting is still specified usually in terms of illuminance on a task plane. I know if Lou Beddoes was here, he would say, well, it's not necessarily horizontal, it can be anywhere you want. The fact of the matter is, most times you don't know where it's going to be, so it's going to be horizontal. And daylighting is still specified in terms of daylight factor. Now, I go back far enough to having sat on the 1973 IES code of lighting, and I always remember someone saying to me, when we were having one of these abstruse arguments on the measurement of uniformity and so on, and he said, basically, it doesn't matter what words you put in, they'll only look at the illuminance tables, right? And that is a problem. It's a problem of how you convince, how you express yourself, how you get people to keep it complex ideas and keep it simple enough to be easily adapted. That's the real problem. So, that's if you're a researcher, right? Okay, and if you want to influence lighting standards and guidelines, then you need to address relevant questions. You need to develop testable models. You need to test predictions in the real world, not just in the lab. And you need to keep the outcome simple. Right? That's the general rule. That's if you want to influence standards, or if you want to influence the general public. Now, the reason I say the third one about testing predictions in the real world is because a lot of the things we're interested in now, having gone beyond visibility, things like mood, preference, behaviour, and so on, are subject to many different factors, lighting being just one of them. And we tend to think, you know, we're interested in lighting, so that must be the answer. And we tend to control all the others. And then in the real world, you find that that's not necessarily so. You know, it isn't. It's a bit like alertness. You know, you can increase alertness by putting people at night, by putting people in blue light to suppress melatonin. But it may not be that increases alertness. It may well be that what you see makes you alert. You know, if you're sitting there in a control room for a nuclear power station, it may not be the fact the red light is flashing, it's red, but it may be what it means is going to cause you some agitation, and that's going to make you more alert, right? So those are the sort of rules you have to play by. And here's a list of what I think would be some relevant questions. Can lighting reliably influence well-being and behaviour? And I emphasise the word reliably, right? Because sometimes if that's the only thing that changes, then you can find it changes. But if you put it in the real world where all these other factors come into it, does that change behaviour? Can lighting be used to reduce circadian disruption for those working night shifts? This is an interesting question. It's not to say that there isn't a need to understand how the circadian system works a lot better and all the other things that go with it. But we already know, this is taking the problem from the other end. We know that circadian disruption is bad for people. So, how can you minimise it? You know, we know it's particularly bad for people working night shift. How can we minimise that? And could we use lighting to do that? That's a relevant question, and that would be easily transferable into standards, right? What would be the role of road lighting in the future? We've talked about autonomous vehicles. Maybe, but don't forget, when they may come along eventually, headlights. But headlights are getting dramatically different. I mean, I come across the other day high beam continuous lighting, which has a sensor at the front which will pick out anything coming towards you and cut out the beam in that area. So there's all sorts of possibilities there. What is the value of individual lighting control? It's quite interesting. If you look at the history of individual lighting controls, what people do, if you put them down and give them a control, they fiddle about with it until they find something that they like, then they leave it alone. Right? That's usually what happens. So in other words, it's deciding, setting where you like things to be. Whether you really want to go around playing with different colours and so on at different times, I'm not sure. And then, can lighting change the atmosphere of a space? I didn't say mood of people, I'm saying atmosphere. We can pick up an atmosphere in a space with people in it, with bottom language, or we can specify look into the lighting of the space and say, well, this is a relaxing space, this is something which makes me sit up and be alert, and so on. Can we produce a recipe for producing both of these atmospheres? That would be interesting. Okay? Will this happen? Well, so to become more influential, it's necessary for writers of lighting standards and guidance to recognise they need to incorporate new knowledge. I mean, if you look at what you basically get is a table of illuminances and lots of things around it. You know? Can we incorporate new knowledge in there? Now, if you're an academic, and most lighting research these days, well, it's not quite true. Lighting research on light sources and luminaires and so on, control systems, is well, it's commercially sensitive, so you don't hear much about it until it's actually the product has been produced. But if you're an academic, you have to realise that cleverness alone is not enough, right? You have to, an academic has a difficult job. He's got to do two things. He's got to satisfy two audiences, I think. First audience is to satisfy their peers, right? If you're an academic, if you want to succeed, you have to publish. And to publish, you have to satisfy your peers that you're doing the right thing, you're measuring the right things, and your analysis is sound, and so on and so on. And that's fine, because it means you've got some basis for saying this is correct. But if you want to influence lighting standards, you've got to be able to communicate. You have to be able to communicate accurately and understandably with people who aren't necessarily experts, but want to know what it means. And that's a tricky thing to do. And the funders of research need to start looking at address relevant questions, I think. There's a certain tendency amongst funders of research to say, well, research is good in itself, which is beneficial in one way, but doesn't mean it gets focused very much, no. So, my conclusion from all that is basically, at the moment, technical ability is not a problem for lighting research. It was a few years ago, but standards in terms of statistical analysis and measurement technique and so on have improved. The problem for lighting research is one of direction. If researchers address questions relevant to standards, lighting research will flourish. If it doesn't, then I think it will diminish as being seen as being irrelevant. That's me, thank you. It's a quick survey of a very, very long series.